Hi guys, in this video we're going to talk about temperature and how it's measured and some different scales and why they're useful. So let's go ahead and get out our Cornell paper and we'll get started. Alright, so remember to put your name and your class period and the date over here. Our objective is Objective 2, temperature, and our essential question is, what is temperature and how is it measured? So, first off, temperature is how hot or cold something is. That's the generic definition. The technical definition is a little bit different. A measure of the average kinetic energy of the particles. Now remember from physics first that kinetic energy has to do with motion. So temperature is a measure of the motion of the particles. So when we have a higher temperature, we have particles that are moving faster, and we have a lower temperature, we have particles that are moving slower. So if we are asked to draw a particle diagram, perhaps of high and low temperature, maybe we could do that really fast. Here would be low, and maybe we'll draw one over here that is high temperature. Remember, our whooshies give us an idea about how fast they're going. So maybe over here in our low temperature, maybe they look like that. And over here in our high temperature, they would be going faster. So I've made them faster by making my whooshies longer. So those are faster moving particles, high temperature, low temperature. So when it comes to measuring temperature, that's kind of a tricky situation. So we're going to jot a little bit about that right here. Measuring temperature, which I'm going to put T for temperature. Temperature is kind of difficult to measure, so we use a couple of scales, but the reason we do that is because temperature is measured relative to something. So think about it. If we wanted to measure the actual temperature by finding the average kinetic energy of all the particles, kinetic energy is mass times volume squared. Half of that is kinetic energy, and so we'd have to measure the mass of all the particles, and then we'd have to measure the velocity of all the particles, then we'd have to add up all the numbers and divide by how many there are. And I've calculated it before. It would take you an ungodly amount of time to be able to do that. So we don't measure actual temperature. We measure temperature relative to something else. And the reason we can do that is because things like to meet at a temperature that's in the middle. So when you use a thermometer to measure temperature, which we might jot that down, we measure it with a thermometer. When you measure temperature with a thermometer, the thermometer is reaching the same temperature as the rest of the particles. The particles have energy. That energy gets transferred around with all the bumping of the particles, and so your substance might start with some energy here. Maybe this is your sample that you're measuring the temperature of, and then you've got your thermometer, which has some liquid inside that we measure how high up it is in order to get the temperature. So when you have your substance, your energy is transferred from the substance to the thermometer. The thermometer changes to have the same temperature, and then you read that temperature from the thermometer. Now, we have a couple of scales that we measure temperature with, and we're going to draw those on the back here. So here we are on the back. So there's the scale that you're most familiar with is probably Fahrenheit. Fahrenheit is how you spell that. It has a little degrees symbol and a capital F for that temperature. Degrees Fahrenheit is how you would say that. This is made by this guy named Gabriel Fahrenheit, surprise, surprise, and he decided that he would mark a 0 on his scale and a 100 on his scale, 100 degrees Fahrenheit and 0 degrees Fahrenheit. And for some reason that I don't really know, he decided that he would use salt water for his 0 degree mark, where salt water freezes. He called that 0 degrees Fahrenheit. Now, he then needed another temperature to measure it with, and so he said, I think I'll stick this thermometer in my mouth. So he used body temperature You might know that body temperature is a little bit less than 100 degrees Fahrenheit, and the story goes that Fahrenheit had a fever when he was measuring his temperature. Or maybe people were hotter then, who knows? But that's what he said, and he said, okay, so I'm going to measure everything relative to saltwater freezing and my body temperature, and he called that scale the Fahrenheit scale. And we're pretty much the only people who use it in the world. Everybody else uses Celsius. Celsius also has the degree symbol, and it's a C for Celsius. And it was invented by a guy whose name was Celsius. Surprise, surprise. But he picked a different set of things to measure for his 0 and his 100. He said 0 would be where fresh water freezes, which is 32 in Fahrenheit. And he said that 100 would be where fresh water boils, which happens to be 212 Fahrenheit. And then he measured everything relative to those two temperatures. Body temperature on Celsius's scale is about 37. So he's got his own scale. Now, scientists really like scales, and they like scales that they can use. So they did a little bit of manipulating. They said, you know what, if I double the Celsius temperature, are the particles really moving twice as fast? So the answer was no. And so in order for scientists to be able to use a temperature scale, they came up with their own, and they called it the Kelvin scale. And it was invented by this guy named Kelvin. And he said, okay, well, if I have a negative temperature, what does that mean? Does that mean my particles are moving backwards? What does that even mean? And so he decided that you should have no negatives, because that doesn't make any sense. You shouldn't be able to have any negatives, and when your particles are cold enough to have no movement, then they should also take up no space. And so what they did was they used a scale. Hang on, I'm going to draw you a better picture. So let's see, we'll start here. Okay, so they took the Kelvin scale, and they said they took a gas, and they had these particles moving at a certain temperature, and they said, okay, this is where it is at 0 degrees Celsius, and this is where it is a little bit hotter, and where it is a little bit hotter. And then they said, okay, so if I draw a line, this is the volume, so it takes up more space. So they went back and they said, hey, look, I can't have negative volume, so this must be the lowest possible. The lowest possible temperature in Celsius is called absolute 0. Well, the lowest possible temperature is called absolute 0. In Celsius, it's negative 273. In Fahrenheit, it's negative 459, which is really stinking cold if you think about it. And they said, you know what, let's make that 0. And so what they did was they said, okay, I'm just going to take my axes here and just move them over so that 0 is right there. So the Kelvin scale has taken the Celsius scale and literally just moved it over. So they didn't do anything other than move that axis so that was 0. That's the new 0. So it's pretty much the same as Celsius, except you have no negatives. So it's still 100 degrees between boiling and freezing. Let me write that up here. So on the 0 degrees Celsius, that's 273 Kelvin. It might also be useful to note that we don't use the degree sign with Kelvin. It's just Kelvin. And it's 373 Kelvin for boiling. So there's still that 100 degree difference there. The difference is where they put 0. It's actually kind of convenient because now we can think about doubling the temperature does in fact double the volume. It's kind of convenient how it works that way. So Kelvin is the scale that we use in chemistry class and most science classes also. So if you have any questions about these temperature scales, make sure you ask your teacher. Thanks for watching.